doctor.
What has you? Look, your eyebrows are all furrowed. You're getting more gray hair by the minute. What's happening, dude?
I'm having a day. So we collect this manufacturing sensor data like temperature, viscosity, flow rate, pressure, vibration, and I need to create an analytic solution on top of that data.
Yeah.
But I'm just tired with the quality of the data that we get. A lot of sensors give me null values very often. That skews up my aggregation when I'm creating an analytics on top of that. They give me some faulty data that I know for sure is wrong. For example, look at this temperature, right? 36 million Fahrenheit. We know for sure that cannot be right.
That's
so
pretty hot.
you see what I'm dealing with.
So what? You're not actually trying to like fix your data file by hand, are you?
Yeah, that's what I was thinking.
Wrong. All right, I have failed you as your instructor if you're trying to do that. All right, you can what? Give me the file. All right, here's what we're gonna do. Give me that file, and we will. I'll show you how you can cleanse that data using Streambase really pretty quickly.
Okay, I just slacked you the file. You should have it in your Slack. Fire away. Help me out, doctor.
Ha! You're funny. All right, let's go. Let's do another. You know, you're my favorite student, so let's have a little training session, my friend. Let me maximize my screen space here. Hold on. All right, so we're gonna start a new. I'll start a new project for you. Here, you can name your own project. What should I name your project? What kind of data are we dealing with?
We are dealing with manufacturing data, so let's say clean manufacturing data.
All right, and it's okay, and we'll just create that project. Hold on, I got some other things that I'm doing right now, so we're gonna ignore those other folders in my area. I'm gonna bring your file into this workspace. We don't really have to do that. Hold on one second. Let me drag and drop it from the download spot. All right. We're gonna have to cut this out, dude, because I need a CSV, not an XLS.
Okay.
Just
I'm pausing it.
You what?
Go.
All right, so I created you this project, and I'm going to drag your data file in and drop it in the resources folder of this project. Now, we don't really have to do this, but it just makes your project self-contained. If I wanted to, export this project and send it to somebody else, maybe I'll send it back to you for your homework. So now that data file is in here, and I'm going to use that data file to create schema. Okay, and what we really recommend people do is to put their schema into an interface file, one central location, so then you can use that schema other places. So when you get to your next phase of dealing with this data, which might be, like if Karnak serves me correctly, you're going to want to probably in a week or so be knocking on my door again to say I need help scoring my data and creating predictions. But we'll cross that hurdle when we get to it, but we'll have your schema saved. So, okay, we create an interface file, and in the interface file, we create a named schema. What kind of data is this again? Sensor data?
Yes, we are dealing with sensor data.
Okay, and then look at this little button right here. It cannot be any easier, Manish. You click this button, and it says, where am I going to copy my schema from? And we're gonna.
Oh, so no manually defining schema. You just pick that schema from the Excel file that I gave you.
Yep. Or either the one on the file system or the one in the project. So I hit file system to start with, but then I remembered that we imported it into our own workspace.
Okay.
It has a header row.
Yes, it does.
Okay, so we click this little button, and then tell me, does this look like what you have in your file?
Yes, it does.
Okay, great. So this is our schema now. And we're going to hit OK. Hit the save button. So now we have this interface file that inside the interface file has a named schema in it. And I would say this is kind of like before you go to paint, prepping, putting the tape on the ceiling so you don't get any paint on the ceiling. It's a little bit of extra work, but it pays dividends. Okay, so whenever I teach, I highly recommend that people do this technique. So now let's go into this file where we're going to create your event flow that's going to cleanse your data for you. And the first thing we need to do is import that schema file that we just created. And so there it is. I just said choose. It's in this particular project. If it was in another project, we'd have to add a POM. We'd have to have a dependency in our POM, but because it's in this project, we can just say import.
Mm-hmm.
All right, so now it's in here, and now it's available for us to use. So all of our streams always start with an input stream, and this is our sensor data in. And we're going to, all streams have a schema, remember?
The one that we just defined?
Yeah, we're going to pick the one we just defined, and now it shows up here, right?
Mm-hmm.
So there's our input stream. And now what we want to do, you said you have some nulls in your data, right?
Yes.
Okay, so we're going to filter out the nulls. Okay, that'll be the first thing we do. We're going to throw out all the tuples that have null values. Yes?
Okay, so that will not negatively skew my aggregations that I'm trying to create. Okay, that makes sense.
Okay, so let's configure this filter. And I always tell you, use good names. So no nulls.
No nulls.
No nulls. That's the name. And for our predicate, so we're going to formulate a statement here using an expression language, a stream-based expression language, and we have a whole bunch of functions that we can use. So basically we say is null, and then we get content assist. I didn't even need to hit a key at all, and it starts bringing up, well, what do you want to test if it's null or not? So do you want to test each of your values, or do you know that every one of your columns has nulls?
Yeah, I think let's start by checking for pressure and temperature for now.
Okay, so if pressure, so I double click on that, is null or right?
Is null temperature. See, I'm becoming an expert now.
Good job.
That's an impressive list of functions on the right, if I'm getting it right? So those are the functions that I can use as an expression language if I want to. Okay.
Yes, all of these. There's a gazillion. That's a technical term. There's a gazillion functions over here. So yeah, we're in this range, right? Is null.
Okay.
But yeah, there's a whole bunch. So so we could take this whole thing and we could say not, or we could pick this box right here, this checkbox, and say create an output port for non-matching tuples. So in essence, if the predicate evaluates to true, it's going to go out port 1. So if one of these two values is null, it's going to come out port 1. And I'm a big fan of logging my bad data.
Mm-hmm.
So let's click on this output stream and we'll call it bad data, all right, or discarded data or something, right? And then if it's not null, right, if neither of these things evaluate to true, then we won't come out that port. We'll come out this non-matching port. We could also change your expression language to be a positive thing, and then your positive tuples would flow out the first port. Kind of, it doesn't matter. 6 of one, half dozen of another is like what we like to say. So so now coming out of this bottom port is going to be data with no nulls. Do you have any other bad data? Do you have anything else we need to clean up?
Yeah, that 36 million Fahrenheit temperature that I had, right? Every now and then, especially for temperature and pressure, I get data that's out of bounds, which I know for sure is wrong.
Okay. So we're going to add another filter. Now we could use the one existing filter and make a really complicated expression, or we could make our code more readable, more maintainable. So I'm a big fan of doing that, modularity. So
good citizen practice.
This filter we're going to call within range, or maybe range test.
Mm-hmm.
Okay, and so again, just those two. You got temperature is what does it really realistically need to be less than?
It's to be less than 500 Fahrenheit for it to be anything meaningful. So we can discard everything that's above 500 Fahrenheit.
Okay, so we could do equal, less than or equal.
Less than
Right
is
now
fine.
it's just less than. Okay, so this guy right now is throwing out temperature ranges, right? We can add to it. What else did you say? So if this thing is below 500, and what else needs to be within range?
And the pressure needs to be under 50 psi, so 50.
Less than 50. Okay, so now in this case, just like I told you, this filter we could have reversed it and made it a positive test. This is our positive test. If our temperature is within a good range and our pressure is within a good range, then we're going to cruise on down the stream, right?
Yeah, that makes sense.
Okay, so if we cared about the bad data, we would check this. We're going to not check it this time, just to have a little bit of a interesting, different case. And now, do you think that's, you want to take a look? Are we at a good spot?
Yeah, I think so. Let's take a look
Right.
how my clean data looks.
Okay, so let's just name our output stream. It's always a good habit, clean data out. And then actually, you want it back in a CSV file?
That'd be awesome.
All right, so here's what we'll do. We grab this adapter, we throw the adapter on the palette. It brings up our big list of all the adapters, and we just type CSV. So we're going to do a file writer. All right, I'm going to write your data back out to a file.
So just so that I'm getting it right, we can bring in data from any of our supported connectors and can send for persistence to any of the supported connectors, right? So the data can be coming from anywhere, can be going. So we process the data, we clean the data, and then we send it out to wherever we want to send for persistence.
Yeah, this is let me remind you, because maybe you haven't been in class in a while. Let me remind you, we're looking at this kind of architectural diagram, right? We connect, that's what you just said. We connect to whatever we have connectivity to. We're in this block right here, right now. We're ingesting, we're cleansing, we're specifically cleansing right now. And then we can either go persist it or we can do something else with it. All right. So in essence, this is a form of persistence. We're going to write it back out to, I'll just put it in my home directory for now. Manish clean data. All right.
So you just drag the CSV output adapter on your palette, on your event flow, and just define where the CSV file needs to go.
I dragged this generic adapter.
Okay.
And it brings up the chooser. And then from here, I typed in CSV to narrow what adapters specifically deal with CSV files. And I picked
there, you pick the
writer.
CSV file, right? Got it. Okay.
Okay. And then I configured that guy. I did not give him a good name. For Manish. Clean data. All right. And and then we on this tab, I said, where do I want my file to go? And I gave a file location.
Understood.
And then down here, like, okay, what if it doesn't exist? Please create me a new one. And if it exists, do I want to append or do I want to overwrite? I suppose I could, yeah, we'll append. It doesn't matter. Okay, so let's run this guy. Oh, wait a minute. So now here's the deal. We're not going to type in all your data by hand. We're going to take that data file you gave me and we're going to pipe it through this event flow that we built.
Okay.
So we do that. This is a quiz, my friend. What do we do that with?
We do that with the feed sim. We create a simulation from the CSV file that I gave you.
Very nice. All right. So again, ignore my other projects going on in here. Source, main, event flow. We find down here, we're going to find our, where do we want to put? Okay, sorry. All right, we're going to do that. We need to cut and do that. Okay, good job. Yep, a new feed simulation. And where are we going to put that feed simulation? Feed simulations, like the data file itself, go in the resources folder. All right, and this is manufacturing feed sim. Okay. Let's say manufacturing data feed sim. And we configure the feed sim. We brings it up right in the editor. We have to pick which stream do we want to feed data to. So inside of this project that I created for you, we get in our .sb app. We have to cut that part out. All right. We get inside of your, oh goodness. This is the same problem we had last time, Manish.
Go.
Okay, so we're going to pipe your data file through, and how do we do that? This is a quiz, my favorite student.
We pick the fit simulation, and we are going to create a simulation based on the CSV file that I gave you.
Fantastic, good job. So feed simulations, like the data file itself, go inside the resources folder. So we pick the location, and we give it a name. Oh, nice voice. Manufacturing data feed sim, okay? And that brings up the feed sim editor. We have to pick which stream do we want to feed data to. So ignore my other project that I got going on there. This is your project, the clean the menu data. And inside of our .sb app, here's your input stream, sensor data in. We pick that. By default, we want to generate, streaming wants to generate totally random data for you, but instead we're going to say read a data file. And
so if you just knew the schema, we could have the tool would have created a random set of data for us.
Yes, and it does know the schema. We're going to give it that, right? So here's your CSV file that we imported into your project. So, and again, you told me earlier when we built our schema from this file that we had a first row as a header.
Yeah.
So we see down here in this bottom area, this is the schema, and this is what it maps to in the CSV that we're reading in. Okay, so we say okay, and I'll slow the data down so you can see it, because I know you're getting a little slow in your old age. Oh, we're so good to each other, my friend. All right, so we'll save that guy, and let's run. And so just to review, what the feed sim is going to run, it's going to pump data to here. If there's a null, we'll see the null in the bad data output. If there's no nulls, we'll come down here, and then if your data is within range, we will see it both on the output stream, and it'll be written to this file, which I'll hand back to you so that then you can go do whatever you want to do with the rest of your data. All right, so here we go. We're running. This will take a minute to start up. And then we'll, instead of manual input, we'll click on the feed simulation tab over here. And we'll send your data downstream, and then I'll drop your file back.
While it's building, essentially I can automate the whole process, right? So I know where my source data is. I can build the connectivity to our streaming application, so it picks up data from there, it clean it, and it can put the clean data wherever we want to consume it from.
Yes, right. Instead of you pulling it off, I don't know where you got this data file from, but instead of pulling it off a data file, 1000%, you can attach to your real live data and be doing this in real time. And then again, maybe you don't want to write it out to another data file. Maybe you want to, send it further downstream and do something more.
Right.
I don't know.
So we do this once and then forget it.
Yeah. So here comes your data. So we're seeing over here, and we can pause this feed sim if we wanted. And once you feel kind of good about it, as a matter of fact, let's pause right now. This is saying that if I click on one of these fields, let me resize my windows a little bit. This guy, sure enough, temperature was null. And so this was the incoming time. And so it came out this bad data stream. And so we can just say resume, and I'm fairly confident this is doing the right thing and it's creating the file. And
I can see another bad data with null value.
I'll slack you back. I'll just speed it up. I don't know how many rows you got in this file, dude.
About this is a small file, about 1000 data points.
Okay, so we see up here it's sending them at a quicker rate, all the way up to 25 times as fast. We should be done in, I don't know, a couple more seconds. and then I'll just Slack you that file back, all right?
That's awesome. So while you're waiting for this CSV file to come back, I'm just thinking out loud here. How about, like, what if my rules are dynamic? What if my rules are changing? So right now, this was a fairly sort of simple rule. I knew, like, I had bad data, but if I wanted to insert some rules in my data transformation logic and wanted to keep those rules dynamic, is that possible?
Yeah, absolutely. So instead of so the filter is a static, but we have a construct called the decision table. So this guy here that looks like the scale.
Okay.
And I actually that's what I'm working on in this other window. If I it'll just be easier. Let me do it over there. So again, over here in my insurance quotes, working on a big decision table file for somebody. And this is its event flow right now. And as I have an SB int that has my schema definition in it, just like I just did for you. And so I'm bringing in this schema is much larger. So I have all this kind of data, including but not limited to, you know, how old are you? What's your gender? What's your driver's license number? Somewhere down here is how many accidents you've been in, how many claims you filed. All right. So there's a lot of things that you could put into your formula for what should your premium be? How much should I charge you for insurance? And so that's something.
Now I know how do I end up paying such a high premium every time. Okay.
So the way you configure a decision table is the way you configure the decision table operator is that you create a decision table file that has those rules in it. And you could create that those rules files with another one of the TIBCO products. You could create it with an Excel spreadsheet, or you can click on it here. This opens the one that I have, but we could create a new one instead. And decision table rule files have two parts. And so you're seeing that in this editor. It has a condition schema. So what are the things that we're going to test or evaluate? You know, so in this case right now, so far I've only built 2 conditions, but I can add a column, right? I can add, you know, the number of accidents you've been in, for instance. And then based on these conditions, if we, just like the filter, we're gonna come to the first kind of predicate and we're going to test, and if you match that predicate, then we're going to take the action that's defined for that row in the action schema. And so this is not really like filtering. We were throwing out bad data. Here we're testing your data and we're in essence enriching it, right? We're adding values.
Okay.
So, and specifically that value that we're adding to the stream is what is this premium that we're about to charge you, or that we've assigned. Yeah, I guess, you know, that we've evaluated just how bad of a driver you are. And so, you know, kind of, if you think about, if we go back to the filter, if you thought about trying to build an if then else with all these conditions, right? The more conditions you have, the more difficult it would be to configure that filter. Plus, if you have if you're using a decision table, then while this application is running, we have a way to do a hot deploy. You can deploy a new version of the rules file to this operator.
So wait, let me get it right. So you have an insurance application running where people can get live quotes based on the information that they provide. So I can change the decision rules on the fly without actually having to bring down the application.
Yeah.
That's pretty powerful. Okay.
Yeah. So this guy, by default, I'm gonna show you. I'm gonna remind you over here in this corner. You mentioned you saw the functions earlier, but we can look at the streams. And so the decision table gets in our original schema. All of these fields are coming in, and what it sends out are 3 different things. One, we nest all of that input schema inside of a top level tuple called in. All right, so there's all our 60 some fields. We also send out then the action tuple, right? So if we go back to our the schema for our action was 3 fields: the actual premium, the actual premium, a code, and a message. So I don't have very many of those filled in yet. Like I said, I'm just starting to work on this project for somebody, and those are in a top level tuple called action. And then it gives us a tuple called rule that tells us which one of these rules applied, which one of these rules caused this tuple to come out. Now,
so that's more like more like the explainability, right? So we took an automated decision. If you want to go back and check the reason behind it, right? The explanation behind why did we make that decision.
Exactly. So one more thing I want to point out while we're on our decision table is this little box up here, this checkbox that says single row execution. If the way this decision table is set up right now, you are only going to land in one of these age ranges. And so if we're testing and we say, oh, here you are in between 26 and 29 and you're a male on line 5, then we're going to be done. We're not going to bother doing any more testing. But you could uncheck that. If you had, I don't know, you might have a set of rules where more than one rule would apply, in which case then you could have multiple outputs from this particular operator. And in particular, this guy right now, there is you can set it up to have like a default, like in a case statement in a very much more
catch-all statement.
Yes, a catch-all statement, right? But we're not going to do that. We're going to leave it checked with, I just want one, right now I'm really just thinking that we want one premium to come out, lest we confuse our users of this particular piece of event flow. So my point is, in talking about those 3 different things that are coming out, I then put this map. I'm changing my data a little bit. In here, I'm saying I don't want any. Right, I put the none. I don't want any of those output fields. Instead, I want the action tuple and the wild card. The asterisk is a wild card. So this is saying, give me all of the things that are in that action tuple nested underneath there, and in essence, promote them to a top level thing. Again, the asterisk says, name it the same thing it used to be named. So instead of action.premium, it'll just be called premium. And so what I'll get if I hover over this arc right here, you'll see what I'm going to get for my output is the premium, the code that was assigned, and the message string.
Okay.
So so this is, again, it's a little bit different than a filter, right? We're not just cleansing, we're cleansing and enriching.
So you said that there might be different kind of, so what other kind of enrichment can we do here?
Well, okay. I'll give you one real quick, easy example. Very common is to add a timestamp. What time or what was the date when we did this, right? So we can add a map, and again, we'll say, process time, right? When did I process this quote? And this particular map is going to add a field, and I don't know, we'll call it timestamp. And we can call the function now. So whenever this runs, whenever a tuple comes through here, we evaluate this expression. It calls out to the system clock, and then it will assign it to a field called timestamp. And so now if we hover over this arc, we see that we're getting the premium, the code, the message, and now this new timestamp field.
Got it. So now is one of the gazillion functions that you referred to earlier.
Very nice job. Yes, there are a gazillion over here. So very you nice. Can call any number of them that you want.
This is awesome. Not just I learned something really powerful. It's not something that's going to solve my problem today, but that's going to help me automate my daily mundane work. So thank you for that. Really appreciate that. And yeah, I'd love to. I think we touched upon a really interesting topic, enrichment. I would love to learn more about that probably on one of our next session.
Yeah, I'm predicting that our next session, well, maybe not our very next session, but I'm predicting the next thing you're going to want to do is enrich your data to predict whether whether something's going to happen on that manufacturing floor. You just maybe don't know that yet.
Yeah, no, that's great. So, so thank you once again. I really appreciate it, Dr. Streaming. And
You're my favorite student.
And you're my favorite teacher. So with that, I think we'll sign off, and thank you everybody. Hope that was you find that helpful as well. And please do register for our next session. And anything else you'd like to add, Dr. Streaming?
No, well, just keep sending in the ideas. We have a lot of people asking for a lot of different components, so
Awesome.
it's fun to pick.
Yes. All righty. Thanks all. Bye.
Good night.